Welcome everyone. Today we are going to solve question number 41 to question number 60. So the question number 41 is given as consider the following statement regarding the gas molecule. The statement 1 is the heavier gas molecule moves more slowly than the light gas molecule. So that is a true statement. According to the Graham's law, we know that the speed is inversely related to the square root of molar mass. This velocity is inversely related to the square root of molar mass. That is also by that we can explain, and by Maxwell-Boltzmann law we can explain. In general, when we draw this kind of plot, this is 1 by n dn by dc, and this is the c. The narrower plot for the means this is for the heavy and this is for the lighter. Okay, so statement 2, the average kinetic energy of the gas molecule is independent of mass. Average kinetic energy is equals to 3 by 2 kt, and that is not dependent on the mass. So statement 2 also correct. So which of the above following is correct respect to the above statement? Both statement 1 and 2 are true. That is true. Is correct explanation correct? 2 is the correct explanation of the statement 2. No, there is no relationship between these two. Or this is not a explanation why the heavier gas molecule moves slowly than the lighter molecule. So option B according to me is correct, but the answer key provided by the UPSC Geo-Chemistry website is the statement 1. But some questions may be wrong in this exam. So the most appropriate answer is option B. In the question number 42, the volume occupied by a 8.8 gram of a CO2 at 32 degrees centigrade 1 bar pressure is this. So we have to determine the volume. V is equals to N/T by P. Now N value is 8.8 divided by the molecular weight of CO2 is 44 into 0.083. This is bar decimeter cube Kelvin inverse mole inverse into temperature is 32, means this is 305 K. Now cut Kelvin, and the pressure is given as 1 bar. Now bar cut, and this is mole unit, mole inverse cut. So we have the final answer about 5.063 decimeter cube. Answer B and option B is correct. In the question number 43, Boyle's law is applicable to isobaric isothermal process, because Boyle's law is P is inversely related to the volume and when temperature is constant. Okay. In the question number 44, which one of the following is not a fundamental assumption? So the gas is composed of very large number of minute particles. That is true, but in this scenario not correct. So that is a true statement, but according to the question not a true statement. In absence of force field, this particle move in a straight line. That is also true. This particle collide with one another only infrequently. Yes, that is also true, because there is so much spaces are available. So in any collision, the total kinetic energy of the two molecules may changes after the collision. No, after the this is completely a elastic collision, so kinetic energy will conserved. So not correct statement will be D. In the question number 45, consider the following statement regarding the distribution of the speeds of molecule. The zero value of the first derivative with respect to a speed corresponding to the most probable velocity. That is true, because if we draw a plot, this is 1 by n dn by dc, this is c, or ump you can say. This is the most probable velocity, ump. So if we take the derivative of this, the first derivative, then we will get the most probable velocity. So this is true, and this value gets 0 at this maximum. at the same temperature the oxygen molecule has the narrower distribution speed than the carbon dioxide. No, that is not true, because more the mass of the gas, more narrower will be distribution. The mass of carbon dioxide, CO2, is greater than the mass of oxygen, because this is 44 and this is 32. So that's why these have more narrower distribution. The area under the speed distribution curve of a particular gas at two different temperature is the same. That is true statement. So 1-3 is correct. Option C is correct. In the question number 46, at what temperature will oxygen gas have the same RMS speed as helium gas? We know that CRMS is root over of 3RT by m, directly proportional to the root over of T by m, or we can say T by m. So two gases, oxygen and helium, m of O2 is 32, m of helium is 2. Okay, and temperature is 25 degrees centigrade, that is 298 Kelvin. So T of O2 by MO2 is equals to T of helium divided by m of helium. We have to determine the T of O2, that is equals to T of helium is giving us 298 into mass of oxygen 32 divided by mass of helium is 2. This is 16. So this value will be 2384 Kelvin. Now it is in the Celsius. So this is actually correct answer if we eliminate all the options. So in Celsius 273 K, then the final value is 211 degrees centigrade. Option D is correct. In the question number 46, for any given molecule the ratio of the average speed, root mean square speed and most probable speed respectively. So in the speed distribution diagram, we know that this is the C most probable, and this is C average, and this is C RMS, means then C average, then CMP. So in this option, in middle there is CRMS, the highest value is 1.73, 1.73. After that the average speed, so between these two A is correct. In the question number 48, according to the Gay-Lussac's law, which one of the following statement frequency about the frequency Z1 of binary collision of a gas molecule at the constant volume is correct? The expression of Z11 is equals to 1 by root 2 pi sigma square C average and n star whole square. Now it is directly proportional to C average, directly proportional to the, this is 8 RT by pi m, means it directly proportional to the T to the power half. So from the first we can answer this is option A. But at constant volume, that P is directly proportional to T, so option A is correct. In the question number 49, which one of the following statement is not correct? In a gas mixture, each gas contribute to the total pressure, that is true. It is not correct. And these are large intermolecular forces in an ideal gas. Ideal gas does not have the intermolecular forces. So not correct statement is B. In the question number 50, a balloon contains a piece of dry ice. Solid carbon dioxide expands when the dry ice sublimes. Which one of the following is true about the system? Suppose this is a balloon. It has CO2, dry ice, and when it is sublime, it is converting to the gas. From solid state, it is converting to the gas, means volume will increases. So the work is done by the system, that is true. In the question number 51, a gas in a piston chamber kept in a constant temperature bath of 27 degrees centigrade expand from the 25 ml to 250 ml very slowly, means it is telling about the reversible reaction. If there are 0.001 moles of an ideal gas in this chamber, the work done during the expansion is, so W is equals to minus inert T ln of V2 by V1. minus moles 0.001 into 8.31 into temperature is 300 K, and ln of V2 is 250 by 25, this is 10. So the final calculation is that minus 2.493 into 2.3, this is minus 5.74 joule. So option A is correct. The question number 52, consider the following statement for an ideal gas undergoing reversible processes. The quantity of work W in an reversible process in a closed system can be found if we know initial state and the final state of the system. This is not a which statements are correct? So this is not a correct statement because W is a path dependent quantity, so it don't have anything to do with the state of the system. The infinitesimal PV work in a closed system always equals to the minus PdV. That is a true statement actually. The PV work is expressed in this. This inerty for every reversible process of an ideal gas. No, this is not correct. Why? Because for an ideal gas, PV is equals to inerty. If we do derivative, then this will be PdV plus VdP is equals to inert dt. Now if we integrated it, then we put integration within the limit, but according to the statement 3, it is only possible when dP is equals to 0, means this is a isobaric process, okay, but it is saying that every reversible process, but that is not a correct one. So option B is correct. In the question number 53, dW and dQ are not an exact differential because W and Q are the path function. Option B is correct. In the question number 54, for a given processes of an ideal gas, dW is equals to 0, dQ less than 0, then for this gas the temperature will decreases, the volume will increases, the pressure will remain constant, the temperature will increases. So let's see. For this gas, du is equals to dQ plus dW. Now when this term is 0, this is equals to dQ. Now the thing is that for an ideal gas, U is the function of temperature. So when this dQ is less than 0, and so du also decreases, so temperature also decreases. Answer A will be correct. The question number 55, a cylinder is fitted with a fractionless piston containing 2 mole of helium gas at 1 bar is kept in a large constant temperature bath of 100 K. The pressure is reversibly increases to 2 bar from 1 bar. The W, Q, del U for this process respectively are. So this is a isothermal process. So del U is equals to 0 for an ideal gas, and W is equals to minus inert T ln of P1 by P2. This is equals to minus 2 into 8.3 into 100, temperature 100 K, ln of 1 by 2. So this value is ln of 1 by 2, this will give negative value, negative positive 1145 joule. So option A is signifying it, and already know that from the first law, Q plus W, and when this is equals to 0, Q is equals to minus W. So both have different sign. Option A is correct. In the question number 56, at the inversion temperature of the gas is A, B or Van der Rohe. Inversion temperature Ti is equals to 2A by RB. The inversion temperature is a temperature. This is a temperature above which the gas warms up, and below which the gas will cools down. So option A is correct. The question number 57, which one of the following state function must remain constant in the Joule-Thomson experiment. In the Joule-Thomson, this is a isoenthalpic process, so D is correct. Question number 58. The standard enthalpy of formation sodium ion in aqueous solution is okay, fine. So we know that when NaOH dissociates, this will give Na plus OH minus. So we can say that del H of heat of formation of NaOH is equals to del H of formation of Na plus heat of formation of OH minus. So from that expression, del heat of formation of Na plus will be heat of formation of NaOH minus heat of formation of OH minus. So the expression will be for the NaOH, this is minus 471 kilojoule mole inverse, minus of OH minus, this is minus 229. So the final value is 242 kJ mole inverse. Answer is C. The question number 59. Which one of the following thermodynamic is correct? So we know that dH is equals to VdP plus TdS. Okay. In this equation, if we say that P is a constant, mean dP is equals to 0. So dH at the constant P is equals to TdS at the constant P. Now if we derived by dt, dH by dt at the constant pressure is T into del S by del T at the constant pressure, and this expression resembles the thing. So option A is correct. The question number 60. For the freezing of 2 gram of a liquid water at 0 degree centigrade and 1 atm, the change of entropy is about the enthalpy of fusion is given. So this is in the Joule Kelvin inverse, means we have to multiply it by moles, and the number of moles of water is 2 by 18. This is 1 by 9. Del S is equals to N into delta heat of freezing divided by the temperature. So 1 by 9 into minus 6000 joule mole inverse divided by, and this is in the mole unit, so 273.15. the value will be minus 2.44 joule Kelvin inverse. So answer C. So option C will be correct. Thanks for watching the video.